rotating and dilating, not around the origin. So everything up till now has been around 0, 0. Now we're going to rotate and dilate around different points. So this is kind of like part 2 of rotations and part 2 of dilations. There's really one simple thing I'm going to do in each one to make it a lot easier. So here's what I'm going to do. We're going to start with rotating, not around the origin. So this one down here is going to say rotate around the point 2, negative 2. That's not the origin. Here's all I'm going to tell you to do on this one. Draw in a new set of axes with your point of rotation as the origin. Then you're going to relabel the other points in relation to this new origin. And then just rotate as normal. So then you could rotate as normal with rules like y negative x, or by counting on the grid. So let me show you what I mean. Plot these 3 points. 2, 5, 1, 3, 4, negative 1. 2. We're going to rotate 90 degrees counterclockwise, so that rule would be negative yx. We're going to about the point 2, negative 2. So plot that point, 2, negative 2, right there. Okay, now here's all you're going to do. That's going to be your new origin. So what I'm going to do, and if you want a straight edge, rule you can, or if you want to draw it in with like colored pencils or something, you can. I'm just going to make that my new origin. So you're going to draw in a set of axes. Right, with 2, negative 2 being the new origin. And now you're just going to rotate as normal. Now, if you do the counting method, it's already set up. Like if I do like this point right here, up 1, right 2, and 90 degrees counterclockwise would be this direction. So then I go along this axis, up 1, right 2, and I'd be right there. Okay? Now, if you're doing this method where you like to do the rule, then you got to change. These points are no longer points I'm in relation to. This is my new origin. So you need to relabel the points. So here's what I mean. This one would now be 2, 1. Right, 2 up 1. This would now be 0, 4, 5, 6, 7. And that would be negative 1, 5. So let's see if this worked. If this point right here is where we ended up for 2, 1. So 2, 1, if I do the rule, if I interchange and make the first one negative. And that's what this one is. In relation to this right here, negative 1, 2 is right there. Let's finish it off. Let's do 0, 7. So I'm going to do the grid method. 0, 7, I'll go up 7, right? That's it. So now I go to this axis and I go up 7. 4, 5, 6. Maybe over here. And how about for negative 1, 5, I'll do the rule. So I interchange 5, negative 1, and make the first one negative. And so from right here, I go 1, 2, 3, 4, 5 down, negative 5, negative 1. And you should look at it and make sure. Does it look, yeah, like this one, 90 degrees counterclockwise? Make sure it looks accurate. Okay, so the only new thing I did was drawing an set of new axes around the point of rotation. That's it. Everything else is the same. So, is there an answer on that one? Thoughts? Let's, I think I'm going to skip the next one. I think that one, it's just another 3 other points and just around a different point. I think what I'd rather do is have you try these in the practice. So let's go and skip that other one for now. Flip to the next page. dilating not around an origin. Okay. Dilate not around an origin. So I give you two methods for this one. And what I call method 2 is kind of the same as the rotations one. You draw a new set of axes, you relabel the points, and then you dilate as normal. Okay, so if you like what I just did on the last one, this is the same thing. Okay. There's another method I'll talk about here when I do the next one. So let's do this one. So quadrilateral. I guess I'll do about these. Quadrilateral fish. 3, 7, 5, 9, 8, 9, 6, 7. So we're going to dilate the figure by half, since it gets smaller, around -1, 1. -1, 1. Okay, so option 1 is just to redraw some new axes. So let's do this. That's not what I want to do. That. So option 1, redraw new axes around -1, 1. And then you just have to relabel your points according to -1, 1, being the origin. So this is now 0, 0. So this point right here, 3, 4, 4, 6. I don't want to write there because that's where our new figure's going to be. So let's see what I can do. Let's see, that would be, well, I'll say my new F is 4, 6. This I would be 6, 8. Right, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. S instead of 8, 9 would now be just 3 to the right, so 9, 8. Okay, and H. This one, 7, 7, 6. Okay, and then you just dilate by half. So as normal, just multiply all the coordinates by half. So F prime, let's just write it down and I'll grab it. Half of 4 is 2, half of 6 is 3. I prime, we got 3 and 4. S prime, 4.5 and 4. And then H prime, 3.5 and 3. And then just graph. Does it say? Yeah, it said dilate. I guess it didn't clarify it. Let's just graph. So according to this point, my new origin, 2, 3, 2, 3. 3, 4, 3, 4, 4.5, 4, 3.5, 1, 2, 3. Right. And then you should look at it. It needs to be half as big. It does appear to be half as big. It needs to be half as far away from this point. And it does appear to be half as far. Okay. If you like that method, it's basically the same as the other one. Great, just new origin. There's another one on here that I think is maybe a little simpler, a little quicker. So I just want to tell you what it is. This is what I call method 1 up here. Basically it's this. Imagine I don't have the blue quadrilateral there yet. Basically it's this. You start at your origin and kind of do a slope and count up and over, or over and up, it doesn't matter, to one of your points. So that would be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. you're dilating by a half. So you just go half as far. 1, 2, 3, right 2. We're going to be at that point. So basically from the origin to your point, you count. And then you go half as far. Like this one would be up 8, right 6. So then I go up 4, right 3. And I'd be right there. And it outlines all of the points. Maybe I'll do that one on the second one. I like to do this one as well. So, any questions of dilating there? The main method I did was redraw new axes. Well, for this, I'll do one more of these. I got triangle sun here. Go ahead and plot the points. How about for this one, I will do that counting method I did. 5, 6, 4. So again, the last method would work, but let's do something different. So dilate this figure by 3, around 9, negative 9. Let's make it 3 times as big, 3 times as far away. 9, negative 9, down here. So again, option method, what I call 2 up there. You could redraw these axes, relabel the points, then get the new points. Let's just do this other method I talked about. All right, so if you like, if you want another method, if you want to do the other method, fine. Here's a different one though. Count from your new origin to from the point of dilation up to here. So it looks like up 1, 2, 3, 4, 5, left 1. So all I do to get in prime is go 3 times as far. So I'm going to go up 15. And left 3. There we go. So I multiplied 5 by 3 and 1 by 3. So right there is n prime. Now I just repeat for the others. So for you, let's just go up and over. So 1, 2, 3, 3, 4. So I multiply 3 by 3 and I get 9. So 3, 4, 5, 6, 7, 8, 9. 4 times 3 is 12. 1, 2. All right, that right there will be U prime. And finally, S. Oh. So let's see. 1, 2, 3, 4, 5, 6. 3, 4, 5. So times 3. Up 18, left 15. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18. Left 15. Times as far away, 3 times as big. Which method do you like better in that one?
That one.
That one? I think it's a little shorter. Some of you might say it's that this way is just it's exactly like the other one.
You gotta be careful about how you count.
On this
The
one?
second one,
Yeah. Yeah, you're right. Just gotta be very careful. Okay, I want to review something with dilating a line, not around the origin. And then I have one other question, which is a very fun one. I guess it's on the back. Yeah, like that one. Okay, so one at the bottom, let's review dilating a line, negative 2x by 1, by a factor of 2. We've done around the origin before, but we'll do a different point. Negative 2x plus 1. Let me just graph that just so we have an idea. It's a y-intercept of 1. Slope is down 2, right 1, negative 2. That's pretty good. Okay, so dilating around the origin, and I'm going to write the equations of what I get here. dilating around the origin. Do we first of all remember that dilating a line will give you the same slope? Right. So both of these I could actually already put in. It's going to be negative 2x plus something. Okay, now for the origin, so right here, this one, if you remember, we just dilate. We did this one on the whiteboard on Monday. Yeah, it's going to be, you multiply this by 2. You're really just taking 1, 1 is your, 0, 1 is your y-intercept. You're multiplying that point by 2, dilating by 2, so 0, 2 is the new y-intercept. And it still has a slope of negative 2. Okay, let's do the other one though. Around 2, 3. So this is 2, 3. So we're dilating. We're dilating that line around 2, 3. Just take 1 point. That's all you need to do. And you can do either of these methods from above. I'm just going to do the one I did on triangle sun, where any point, doesn't matter, I'll just choose this one. I count to that point. So left 2, down 2. I'm dilating by 2, so then I multiply that distance by 2. So instead of going left 2, down 2, I go left 4, down 4. And that will be a point on my new line. Now instead dilate by 3, I would have gone left 6, down 6. Matter half, left 1, down 1. But since this was 2 and 2, I then went left 4, down 4. Okay, so to get the line, I just need the y-intercept. So I count the slope, down 2, right 1, down 2, right 1. It's negative 5. Okay. All right, I got one more. Anything on this page?
No, I have a question. I
Yeah.
like curious how you did the origin.
What part A on this one?
Part B.
Oh, 2, 3.
Yeah.
So I got the point in green here. That's what I'm dilating around. So my new line has to be twice as far away from that one. And so what I'm doing is I can count to any point on the line. It could have been this one or this one, any of them. I just counted to that line. Sorry, to the line, to that exact point. And because of the scale factor of 2, I doubled it. So instead of going left 2, down 2 to get there, I need to go twice as far. So I multiplied each of these by 2. And so I was going left 4 and down 4. And that'll give me a point that's now on my line. And we already knew that the slope is going to be the same. As we dilate lines, the slopes are always the same. So that's why I then counted down 2, right 1. And then there, that's the y-intercept. So then I just said, all right, it's negative 2x, that's the slope, the y-intercept is negative 5. And you could have chosen any point. I could have chosen this one. It would have been left 1, down 4. So then I would have gone left 2, down 8. And I would have been right there. So any point would work. Does that help a little bit? Last one, let's flip it over. I really like this type. These triangles are similar. Triangle DEF is the image. So this one is kind of the complete opposite of the last one. Instead of trying to find one of the new triangles, they give you both triangles, but they say what was the scale factor and what was the center of dilation. All right, so we gotta plot both of these. 1, negative 2. Negative 1, 3. 4, 2. 7, 0. 1, 15. Yeah, sorry about that. This one. Sometimes they get these the way I want. You gotta go off the grid. 16, 12. It's basically just kind of extended that a little bit there. This down. Okay. So once you have a, graph, and if you really needed to on a test or something, I try to give you numbers on the grid, but you can have additional grid paper. Let's first find the scale factor. Yes, it was yesterday or Monday I mentioned where it's not always going to be where you can just look at the line straight on, right? They're horizontal and vertical lines. That's all right. Just count some slopes. You can actually do Pythagorean theorem and find distances, but I'm just going to look at some slopes. So for example, let's look at the slope along this line. It's down 1, 2, 3, 4, 5, and right 2. Go to the corresponding side and count down and over. That was at 15, so this is down 15, right 6. And by the way, we are, let's see, be careful with which one we're starting with. The triangles are similar. DEF is the image, that's the bigger one. So we are going small to big. Small to big. So based on these numbers then, what do you think the scale factor?
3.
3. We went 3 times as far. Right, 5 times 3 is 15, and 2 times 3 is 6. If it was big to small, it would have been 1/3. Okay, so that answers this. Next question is center of dilation. So it's going to be a point. Right? Normally I say dilate around the point 1, -1. So the center of dilation, here's what you got to do. You take out your ruler, your straight edge. Well, just imagine you have one. Okay, just. Yeah, good. You take out your straight edge and you connect the points that match up. So this point and this point were ones that matched up. And so I'm going to make a line through those and extend it down. If you want to watch first on this just to see where it's going. Here, these 2 points go together, so I'm going to extend that line. You could actually stop there. If you see, it's going to be where they intersect. But I'll do the last one. That point and that one. That point and that one go together. So as I see, I just draw in lines between the points that matched up. And you see, it basically just tells you, right there where they intersect. That was actually the center of dilation. So, just if you want to make a note there, here I put it. To find the center of dilation, draw on a line between each pre-image and image point. The center of dilation will be where all the lines converge. Okay, so that is -2, -3. I like that one. Okay. Anything else I can answer on rotating, dilating, not around the origin? Let's do a quick 1-minute recap. So rotating, not around the origin. I only told you one method. Basically, just you got to draw new axes. Go to the point, draw new axes, relabel the other points, rotate as normal. For dilating, you can do the same thing. You can draw the new axes, relabel the points like here, and then do the dilation as normal. Or, I showed you in this one, you kind of do this counting method. The line one, did that, and then here you draw in the lines to find the center of dilation.